In this video, I'm going to go over using two different theorems, actually just one theorem in this video. This is going to actually be part one of 2 parts for 10.4. Right, so in class, we'll kind of go through this first part video for those of you that were absent on Friday, March 28th. And then we'll do part 2 in class on Monday, I believe that's the 31st. Okay, so the first thing that we're going to do is, again, if you were in class, then you've already kind of formalized this, going from the CLT where you discovered a lot of the stuff, putting this down in class. If you were absent, you obviously didn't get a chance to do the CLT. That's okay. So I'll kind of go through the vocab here and how we're going to use it going forward. So the first thing you notice is the inscribed angle. You'll see a blue dot on the circle, and then you can see that the 2 chords in blue create that angle, and that is what makes it an inscribed angle. So the vertex has to be on the circle, and the 2 sides of the angle have to be chords of the circle. Now, you'll also notice the intercepted arc, which is in orange, right? So that is the arc of the circle that is intercepted by that inscribed angle. And there is a numerical relationship, which we proved in class, where the angle is half the length of the intercepted arc. So I put here in purple, depending on which direction you're going, if you're going from the angle to the arc, you're going to multiply by 2. If you're going from the arc to the angle, you'll divide by 2. We'll practice doing that today on this video. All right, and then we have the inscribed right triangle theorem, where if you have a right triangle is inscribed in a circle, then the hypotenuse is the diameter of the circle. All right, and we're going to go both ways with that, right? The converse of that is if the hypotenuse of this triangle inscribed on the circle is a diameter, then it is a right triangle. So we're going to go both ways. I'm going to use that converse in a question soon. Okay, so let's do some examples with those vocab, values, and theorem. So first couple here, it says state if each angle is an inscribed angle, and if it is, name the angle in the intercepted arc. So this first one, again, you're looking for is the vertex on the circle. It is. Are the sides of it chords? They are. So yes, this is an inscribed angle, and the angle is going to be angle BAC. Also acceptable to put angle CAB. Number 2, first thing I notice is the vertex K is not on the circle. It is inside the circle. So this is not an inscribed angle. Okay, number 3. Again, when I look here, I see we have that X is on the circle. We have those 2 chords there are making the rest of the angle. So yes, it is an inscribed angle. And this is angle, I'll say VXW. Also acceptable, angle WXV. And last but not least, number 4, you'll notice that actually the vertex of this angle is the center of the circle, right? Center M is the center, or circle M, you can see M is the center. So no, this is not an inscribed angle. Okay, let's get a little bit more complicated here. All right, now as I do these, if you're watching the video and you you're not in my class or you missed it, right, you might actually start to see how to do some of these questions, and you might go down a different path than I go down. That's okay, right? Your brain might see different avenues that will lead you to the same destination. It's going to happen a lot with these circle questions. So, if you want to go the way that I'm going, great. If you find a different avenue that also works for you, absolutely, totally fine, right? We should meet at the same ending, though. We should get the same answer once all is said and done. Okay, number 5. For all of these, we're going to find the measure of the arc or angle indicated. So we have question mark here. So we're trying to find this question mark. All right, and that is an inscribed angle. You'll notice that we have that vertex. We have these chords make up the sides of the angle. So what I want to do is I want to highlight this intercepted arc, BC. And I told you guys at the very beginning, I'll go back up here, there is a mathematical relationship between those, that if you know the intercepted arc and you want to go to the inscribed angle, we're going to divide by 2 to go that direction. So if this arc, I'll write it down, so the measure of arc BC is 80 degrees, then to go to the measure of angle BAC, we're going to do 80 degrees divided by 2. All right, so the measure of angle BAC is 40 degrees. Remember, that's the relationship, okay? All right, let's do number 6. Now, this one is asking for us to find arc DC All right, so that's what I'm trying to find. So the measure of arc DC. And I notice that we do have an inscribed angle here of DBC. So if I can figure out what this value is, then to get to the measure of, you know what, I shouldn't use question marks since I already use it. If I can figure out what this is, I'll use box. If I can figure out what that box is, then I can use that relationship to double that value to find the measure of the intercepted arc, okay? So this is a triangle that's been inscribed. So 49 degrees plus 70 degrees plus box, that angle is gonna be equal to 180 degrees. So that's gonna be 119. So subtracting the 119, try to draw a better box there. To the other side is going to be, I believe, 61 degrees. Yeah, that should work. All right, and then again, that's not the answer because this measure of arc DC is going to be double that, so it's 2 times 61 degrees. So I'll bring that down here. You know what? Actually, make this nicer. Let's just go ahead and move that down here. So the measure of arc DC is going to be equal to 122 degrees. All right. Okay, let's keep going. Number 7. All right, number 7 is a good one. Again, this is one of those where you might have to see different avenues. I'll show you the way my brain thinks of it, and then we'll go from there. So what I notice here is that I'm trying to find arc PD, right? That's ultimately, I'll put that here at the bottom. The measure of arc PD. That's what I'm trying to find. And if I look at the inscribed angle for that one, that's angle PED or angle DEP. So if I can find the measure of angle PED, that's going to help me to figure out that arc of PD or DP. Okay. Now, one theorem we looked at the very beginning in these notes was the inscribed right triangle theorem, which says that if a right triangle is inscribed in a circle, then the hypotenuse is a diameter of the circle. And I told you can also go the other direction. The converse of this is that if you have a triangle inscribed in a circle and the hypotenuse is the diameter, then it must be a right triangle. So I'm going to use that converse of that theorem to show you that this, try a different highlighter color, this FD diameter is the hypotenuse of that triangle, all right? So that means that this angle here must be a right angle. So that triangle FED is a right triangle. Now, if this 35 degrees goes there, that means that the other angle, the one I care about, angle PED, is complementary to that 35 degrees. So subtracting that 35 degrees from 90, I get 55 degrees. So angle PED is going to be 55 degrees. All right, and like I said, if I know that, I can get to my answer by multiplying that by 2. So the measure of arc PD is going to be 55 degrees times 2. So the answer that I want for that question mark is going to be 110 degrees. All right, again, like I said, there's lots of avenues for this one. That's the way my brain saw this question. Okay, let's go to number 8. Okay, number 8, I'm trying to figure out this arc FV, right? That's ultimately where I'm going here, a measure of arc FV. That's what I want to find. Now, when I look at the values that are given to me, I notice I have arc GH. Right there is 168 degrees. And then I have some angles in this inscribed quadrilateral. So let me use my understanding of these angles that are made. So here's angle GHV, which is 65 degrees. So if I look at the intercepted arc here of arc, oops, I'm sorry. Let me get rid of that real quick. And let me actually get rid of this, even though that is what I'm finding. But if you look at my intercepted arc for that angle GHV, that would be this arc right there, arc GFV or VFG, and that's going to be double that value of 65. So the measure of arc, let's say, we'll say GFV is equal to 65 degrees times 2. Let's actually put that 2 in front. Okay, so that's going to be equal to 130 degrees. So this right here in yellow is 130 degrees, okay? Now, when I look at this other angle they gave me, this 119 degrees, if I use, try a different color, they're going to overlap, it's just going to be what it is. But if I look at this angle right there and look at the intercepted arc from that. I'll try my best here. For arc F, G, H, all right, so the measure of arc F, G, H is going to be 2 times 119 degrees, which is going to be, what's that, 238, I believe. Okay, so then if this 168 is arc GH or HG, and I just did arc FGH is 168, I'm going to subtract 238 degrees minus 168 degrees, which would give me just the measure of arc FG. Okay, so the measure of arc FG is equal to, that's 70 degrees. So this right here, this little piece is 70, and we already said that this whole thing, I'll just use my marker or my pen here, this whole thing here is going to be 130. So if I want to find this smaller piece, I'm running out of colors. Oh, yeah, I got more colors. If I want to find this smaller part here, I need to take that 130 and subtract 70, which would give me the measure of arc FV, which is ultimately what I want. So the measure of arc FV is going to be 60 degrees. Now, I know the colors probably got a little out of hand there. That's on me. Just try to do your best. Try to rewatch this, maybe go slower, or come ask me in class about this one. Okay, let's do, I think we have 4 more, then we're done. Okay, this one, I'm trying to figure out X for number 9. And again, I'm given this angle 110 degrees, all right, that inscribed angle. And I'm going to look at the arc that is made. So arc KRQ is the intercepted arc for that angle KPQ. So this arc KRQ is going to be 110 times 2, right, which is going to be 220 degrees. Now we already know there's a smaller arc here, a minor arc KP, which is 50 degrees, and there's one more part of this circle, which is 30x. So that's all the way around, which is 360 degrees. So if I do the 220, right, which is that one that's like all the way around here, that's KRQ, then I add 50, which is that small piece, arc KP, plus my last minor arc of PQ of 30x. That should all equal to 360 degrees. So 270 plus 30x equals 360. Subtract the 270 over, and you get 90. So x equals 3. In this case, they just want me to solve for x. All right, less colors there. I think that was a little bit easier to see. Let's try 10. All right, this one I think is more straightforward. You're given the inscribed angle of FGE, the intercepted arc they're also giving us, and the relationship between those is going to be that if I were to take my inscribed angle and multiply it by 2, that should be equal to the measure of that intercepted arc, or 192 degrees. Now, if you wanted to, you could take that 2 and distribute to write 62x plus 6 equals 192 degrees. But I'm actually going to take a different approach. I'm going to divide by 2 first, just to make the number smaller, to get 31x plus 3 equals, I believe, 96 degrees. Let's see, 18. Yep, that should be good. All right, move the 3 over with subtraction, you get 93, and actually x equals 3 again. All right, which is just a coincidence. It's not always going to be 3. Okay, last 2. Find the measure of the arc or angle indicated. So we're going to find the measure of angle NLM. So I'm trying to find NLM, which is this angle here. Okay, now I do see that that is a inscribed angle. You'll notice that the intercepted arc is arc NM, all right? And what I noticed is that one of these chords is actually a diameter, right? Did you guys see that chord LN is a diameter? So if that's a diameter, then this right here, let me highlight it right here, is half of the circle in yellow. So if that's half of the circle in yellow, and we have this measure of that arc LM, this is the measure of arc NM, then those added together have to be equal to 180 degrees. So I'm going to add 7x minus 10 plus 13x minus 10 equals 180 degrees. So I get 20x minus 20 equals 180. Move the minus 20 over the addition, and you get 200. So x equals 10. Again, I'm not solving for x here. I mean, I am, but I need to find the measure of NLM. So I'm going to find the measure of arc NM. Oop, that's not an M. Let's try again. Okay, which is going to be 10 times, let's do it correct here, Douglas. 7 times 10 minus 10. So that arc is going to be 70 minus, that's 60 degrees. Okay, so the angle, remember, if I'm going from the intercepted arc to the inscribed angle, we actually divide by 2. So the measure of angle NLM equals 60 degrees divided by 2. So that angle NLM is 30 degrees. And that's what I'm looking for. All right, very last one. Here we go. Number 12. And again, this is part 1, right? So tune back in a couple days. I'll make sure to post 10.4 part 2. All right, we're trying to find the measure of arc FGH. So right here, FGH is a major arc, FGH. Now I have an inscribed angle with that one, right, of FAH. All right, and I also see that we have another inscribed angle, FGH, which sets up to that arc F. Ooh, let me use a different color. That arc FAH. And if you notice, those two arcs, so in my green highlighter and in my yellow highlighter, that's the whole thing, right? So if I can figure out the measure of those together is going to be 360 degrees. So I'm going to start with the 21x minus 2, all right, which is going to give me the measure of arc FAH, but I got to multiply by 2, right, to move out to that arc, plus the measure of that other angle, 38x plus 5, but again, also got to multiply by 2 to get out to the intercepted arc of FGH, and all that together will be 360. Again, you can feel free to take that 2 for each of these and distribute and combine their terms and solve it, totally fine, but they share that 2. So I'm going to factor out the 2 and put it in front. And then I'm going to move it over with division. Just make my life a little easier, especially since right now I haven't used a calculator for this video and I'm not going to. So that's going to be equal to 180 degrees. Combine like terms, you get 59x plus 3 equals 180. Move the 3 over with subtraction. You get 177. I know 60 times 3 is 180, but I want 177, so 3 less than that, or excuse me, yes, 3 less than that, which is 1 less for my answer. So 59 times 3 is going to be 177. Again, if you have to use a calculator for that, no big deal. Now we're not done. That's just x. I do want to find FGH, right, that arc. So I'm going to find the inscribed angle, which is at FAH. So the measure of angle FAH is equal to 38 times 3 plus 5, which is equal to, so let's see, that's 40 times 3 would be 120, take away 6, so that's 114 plus 5, so that's 119 degrees for the measure of angle FAH. And if I'm going from an angle to the intercepted arc, I need to double it, so multiply by 2. So the measure of arc FGH equals 2 times 119, which is, if that was 120 times 2 would be 240, but it's 1 less than that, so take away 2. So the answer is 238 degrees. All right, guys, that is it for part 1. Don't forget to check back in for part 2.